guys. Hi guys. Hopefully, let's see. I will make a comment on the previous live stream. Hopefully you guys can find, let's see. Hopefully you guys find that I made a new channel just to wrap up, because I still have like an announcement that I was planning to make about our next class session, as well as finishing up the last bit there. So if anybody still has the other live stream open, and you could comment on there saying like, hey, Caitlin made a new live stream, head on over there. That would be great. Let's see. I don't see it here on my YouTube channel, so I can't get back into the former live stream and comment on it. But if any of you guys could potentially comment on that other live video, in case anyone's still there, and say, hey, Caitlin made a new live stream, that would be awesome. That was totally my fault. My computer was not plugged in like I thought it was, and it ran out of battery. So that was totally my fault. And I'm sorry, and I won't do that again. I promise. I promise to try. So let's see. We've got 4 people here. Looks like we have echo back. I basically had finished everything that I wanted to say about hotspots. That's almost completely it. Pretty much just had like I was halfway through like the last sentence that was important about hotspots, which is such a bummer. Let's see. We still only have about 4 people. Will the other ones save to watch later too? I hope so. I hope so. I can't see it right now on my YouTube channel, but I will be really, really sad if it doesn't get saved. It will be very sad. Let's see if I can open in a new tab. Let me know, were any of you guys able? Let me know, were any of you guys able to comment on the previous live stream and tell people that I started a new one? Let's see if I can't. Still trying to see if I can get a few more people back. Nope, I definitely don't see the video on my channel. What a bummer. Really hope that it didn't disappear into like oblivion. But in any case, this live stream should stay up. And so people who left and are like, I'm tired, hopefully they'll come back and watch the rest of this. So basically what happens though, where we left off was we were talking about the fact that these plates do move over that hotspot that is stationary. And this process of building volcanoes keeps happening as the plate moves over it. So I just talked about Hawaii. The island of Hawaii has several volcanoes on it. And I don't know how much you guys follow like the volcanic activity on Hawaii, probably not much. Most of you probably don't. I do, because I'm a geologist and I freaking love this stuff. But on the edge of Hawaii, you've got the island here, right? And you've got some volcanoes on it. On one of the edges, there is a new volcano forming at the edge of the island. And it's still submarine right now. It's still underwater, but it is slowly building itself up to attach onto this landmass, right? It's slowly coming up there and being like, hello, I am going to create more landmass. Basically, this is the record of that hotspot sliding over the plate sliding over that particularly hot spot in the mantle that's causing that volcanic activity. And as the plate moves over the hot spot, we're just going to continue to get volcanoes building up, right? And some of these volcanoes, the plate might be there for a while. So some of these volcanoes are going to be able to build all the way up so that they create another island on the Hawaiian chain, right? Some of them, though, are going to not necessarily be able to reach the top, the surface of the ocean. But basically, as the plate shifts over this hot spot, right, we're going to get, oops, wrong way. We're going to continue to get these like islands that form, right? We'll have a nice, clean tectonic plate, right? Moving over that hot spot, and then it's going to build an island, and then it's going to move it off to the side here, right? And then it's going to build another one right next to it, right? Another volcano there. That's my volcano. I can actually draw really well, I promise. Just not that fast. So that's essentially a hotspot there for you. And just to throw a wrench into things and to complicate your life and the lives of all of us geologists out there and the theory of plate tectonics, there is another theory about hotspots. And that is the theory that hotspots aren't stationary. And I feel that in order to be academically honest, I need to mention this, although a lot of 101 instructors might not mention this just because it can cause confusion. Let's see, Avi says kind of. Yeah, the video is still up. Oh, thank goodness the other video is still there. I just can't see it for some reason. The wonders of, technology and the internet. I know other people who have had that same problem with live streams. So some people do theorize, though, that some hotspots can also move and migrate themselves as well. Found it in your history. Great. That's where I will check too for that video in my history. So Yellowstone is one hotspot that the idea, some people believe that hotspot has migrated and that's caused some of the volcanic activity in Oregon and Washington, and now is over underneath Yellowstone, creating that wonderful little park there for us to visit that we hope never erupts, because if it does, that'll really mess up our planet for a little bit. But there is also the other idea that that hotspot is stationary too, but that the plates upon which the west coast of North America sits is doing some really interesting movement and doing some really interesting rotation and whatnot. And that's actually an even newer idea than that's a pretty recent idea that's still being looked into a lot. But for the purposes of your lab, we're sticking with the idea that hotspots are stationary and that plates move over the top of them. So that concludes lecture, all that we were going to talk about today. However, there are a couple of announcements that I need to make, specifically about materials that you'll want to bring, some household items that you'll want to have on you for next week, as well as, so you'll want to bring with you or have with you, you probably don't need to bring it because hopefully you're staying home. You'll want to have on hand during lecture your rock kit. We're going to be going over the first 6 samples that are in there. We're going to be going over minerals next week. Yay. It's actually my favorite topic. I love minerals. It's kind of hard to choose a favorite topic, but it's definitely minerals. You're going to want to bring with you some pennies. Now we have to be specific here, though. You can't just bring any penny with you. Hopefully you've got some like pennies around the house. If you go to the grocery store, maybe you can ask a cashier though for like some change and acquire some pennies. And hopefully you're looking for a specific type of penny. You are looking for one that was made in 1982 or prior to that. You don't want anything that was made in the mid to late 80s, the 90s, or the 2000s. You need something that a penny that was made 1982 or older. The reason why you need an older penny is because these pennies are actually solid copper. Pennies today that were made in 1983 and more recently, they have just the thinnest, barely there copper coating, and then the rest of it is like zinc, I believe, beneath it. So it's not going to work. Our rock kits have 6 minerals in them, but I am increasing the number of minerals by 1 because copper is actually a mineral. So I'm going to increase the amount of mineral samples that you have by asking you to bring a copper penny. We can also use the copper penny to test other minerals too. More on that though next week. So if you have the ability to acquire a copper penny, one that is 1982 or older, please do, and have that on hand with you. The other thing that you're going to want to bring with you or have with you is pencil lead, right? And it can be either a mechanical pencil or a traditional pencil. Pencil lead is not actually lead. Yes, it used to be lead. Thank God it isn't anymore. Now they use graphite. Graphite is also a mineral. I am again expanding your mineral kits with household items that are made out of minerals. So those are going to be 2 additional minerals that I hope you guys can acquire between now and next Monday. If you're unable to, though, don't sweat it. But if you happen to have the opportunity, it would be great if you could acquire some pencil lead and an older penny. The other thing that you'll want to have with you is some glass that you are not afraid to get scratches on, because we are going to use glass to test our minerals in our kits. So you might be like, glass, that's weird. Where am I going to get glass that I don't mind scratching up? I don't feel like scratching up the glass cups if you have glass cups or whatever. So a great way to, something that you can use like a salsa jar or a pasta sauce jar. That's because usually people just recycle that glass, or perhaps like a beverage of some kind. This is like an apple cider vinegar one, or like Snapple or something like that. Geologists, it is a running joke in the geology community that geologists love to drink. So I have seen people use beer bottles or wine bottles for this. And I have seen in the back of Okay. So I've seen in the back of at least one geology classroom wine bottles that were sitting on the back shelf, empty ones, empty. They were empty. People were like, why are there empty wine bottles? It was glass for testing minerals. And when you looked at the wine bottles, they were scratched to heck. So yeah, you're going to want a piece of glass that you do not mind scratching and getting scratched up. Let's see. I think that is it for the items that you're going to want to have. So, all right, I'll post that announcement too on Canvas, because I don't want people to miss it and not have those items on hand for next week's lecture. So does anyone have any remaining questions? Would anybody be interested in setting up a like a live chat, like a Zoom or a Hangouts or something? Go ahead, and for the 6 of you that are here, 5 or 6 of you guys in the chat, just be like, yes, no, want to set up a meeting, I'm good. So Michaela would. All right. Would you prefer Hangouts or Zoom? Which one's easier for you? Anybody else? Rachel's good. Michaela says either one. Echo's good. Anybody else want to join and have a preference for Hangout or Zoom? And this will be it, by the way. So we're not going to be doing any other like lecture, but just if you guys like have questions or you want to go over anything. So Michaela says Google Hangouts. Not as familiar with Zoom. Okay. So let me start getting that set up then. So for a video call on Hangouts, I believe that I'm going to need your email address, preferred email address. All right, and if anyone else would like to join, go ahead and add your emails. All right, so I've sent an invite to Michaela. It looks like there's still 4 people watching. If any of you guys want to join the Hangouts meeting, go ahead and type your email in the live chat, or you can just head out, and I will see you guys on Monday. See you guys on Monday. All right. Hi, Michaela. I got it right. Michaela? Awesome. All right. So if there's any questions you have, I am definitely willing to bet that you are not the only one. So is it okay if I leave the live stream up as well? They won't be able to see your webcam, but they'll at least be able to hear like the Q&A.
Yeah, of course. That's totally fine.
Okay, cool. So it's nice to virtually meet you.
You too. So really quickly, I just started the lab last night, just early, to try to get a jump on things. And I just kind of wanted to make sure, because when you're doing it alone at home, it's kind of difficult to be like, am I doing exactly what I'm supposed to be doing? Like it's hard
Absolutely.
kind of without guidance, essentially, sometimes to start labs completely on your own.
Absolutely. Yeah.
So I was able to just measure the distance with a ruler and then kind of convert that from centimeters that I was using to kilometers, or more specifically millimeters to kilometers.
Mm-hmm.
And then from there, I was able to multiply by the factor of 100,000, which it said to get you from kilometers to actual centimeters of space or distance between the islands.
Right. In like real life difference as opposed to just on the map. Right.
Right, exactly. At first I was like, oh, centimeters, and I started filling it in. I'm like, oh my gosh, that's not what it's asking.
Yeah.
So I figured that part out. And then just to kind of double check my numbers, I ended up getting 14.75 centimeters per year as an average speed of crustal movement.
Let me check really quick. Let me grab my lab handout because I don't have the numbers memorized.
No, that's perfect. I wouldn't expect you to.
Let's see. Let's see, for an average rate of crustal movement overall, you said you got 14 point, what was it?
14.75.
Yeah, that's definitely within like the acceptable. Different people are going to have different numbers depending on how accurately you measure on the map, or just how you measure on the map. And then when you like convert all of those numbers, but that's definitely within that acceptable like window of numbers that people are going to get.
Perfect. Yeah, I had more specific numbers, and because it said approximate, I just kind of rounded them off to whole numbers.
Yeah.
Because I mean, you can split hairs, but at the end of the day, you're taking a ruler and you're approximating. So
right.
I ended up just kind of rounding off to the nearest whole number.
Yeah.
Just based off of general math rounding rules. And then what kind of slipped me up, I mean, it was late when I was doing this last night, but was kind of the direct. So the question number 6 says, based upon the Hawaiian Island diagram, which direction was the crustal plate apparently moving when the islands formed? And so are we kind of doing like directions based off like northwest, or like, are we trying to, yeah, I guess I'm a little stumped as to like what specifically it's asking for. It's asking for obviously a direction, but that could mean a lot of things.
Absolutely. So it is asking for like, you'll want to say it's moving to the, X direction. And so how you determine for this lab which direction, northwest, southeast, somewhere in between, it's moving. Imagine with me like a candle. I don't really feel like lighting a candle and holding a piece of paper over it right now, but imagine with me if you did that and you held a piece of paper over it, you'd start to get like a scorch mark. Right. And that's essentially our volcano for now, and our island of Hawaii. And if I move the paper over it, I'm going to get a trail of scorch mark, right? And so from that scorch mark, you can tell that I was moving it one direction versus the other direction, right? So that's essentially how you would find the answer to it. I don't want to like say the answer,
right?
And it's a little trippy to think about it, but mull it over. And if you're still just like, I'm still not getting it, you can email me and just be like, I don't get it.
I feel like I do. I think I'm getting tripped up because I'm like, okay, well, like obviously based off of like the direction of it, like it looks like it's moving to the southeast. Like that's just kind of its general path.
Mm-hmm.
I think I'm almost overthinking it. Like, well, it can't be that easy. Like there's got to be more to it than it's just moving in a general southeast direction.
Right. So one thing too to be careful is it really is as simple as like what I was saying with the analogy of just looking for the path of the scorch mark, right? It's not uncommon though for people to still get it wrong. So, and to get it backwards as well. So, because it is trippy to think about.
Okay, because we're talking about the plate moving as like past it as the
right.
as the hot spot is staying in one place. And so okay, so I get what you're saying. It's not necessarily like what general arc are these islands from oldest to newest, but it's more just like how was the plate moving in correspondence to the islands being formed?
It does have to do with oldest to newest. So if I have my piece of paper like over the candle or even over like a pen, I could do this with a pen. So say I'm starting out, let's see how this is kind of looking here. So if I'm starting out like right here, and this is difficult. Let's see, a little something to write on. Say this is my hot spot and this is my tectonic plate and I'm moving this way. This is the oldest spot, right? And this is the newest ink that I laid down, right? So if we do like kind of like a compass direction of so see if I can hold that up so that the camera can kind of see it. North, south, east, west. This is the oldest, progressively getting younger, and this is the most recent ink that I laid down. I would say that this plate is moving, and I'll do it again. So I would say that this plate is moving to the west.
Right. That's what I was. As soon as I said southeast, I was like, just because that's like the arc of how things are going. Like, yes, they're it would look if you were to connect the dots like they're going, to the right and down each time. But it's like in the way that the plate is moving to make that happen, it has to be moving away for the new islands to come out the other side.
Right. Because we start with a clean slate, and then as the clean slate moves over it, it creates the blemish or the trail or the marks. So the oldest stuff is in this analogy. I can hold it up here. People will probably come back to this live stream when they also realize like, I'm not getting this. Because this happens. This is the most common question I get. The oldest stuff is in the west, right?
Right.
And that's indicative because it's moving to the west. So,
okay.
Yeah.
I get it. I think I get it at least. I guess my next question would be, like I was saying before, like directionality, because it's not just like a straight line. Like what you've drawn is like obviously
straight
due west, but it couldn't be more straight, and that's not the Hawaiian Islands, obviously. So, are we kind of doing that like dual directionality where it's like northwest? Are we putting in those? Okay, perfect.
Yeah.
Cool.
And it's also interesting too because there's a little bit of a curve to the islands. Part of that though is because the Earth is curved itself.
What? No flat Earth?
I saw a T-shirt like a year ago that it really got me. I was laughing about it for like a couple minutes. It was a NASA shirt and it said "not flat, we checked."
Good for you. Like people that are actually like real into that.
Yeah. It's very, very interesting. I actually know there's another student on campus who's very involved in the geology and whatnot, the geology community that is on campus. And he claims that he believes in a flat earth. I am skeptic though that he actually believes it, but he's kind of like all about like the chaos and all that jazz. And
I cause a riot.
Try to cause, yeah.
Trying to stir some feelings.
Yeah, like get a, like a rise and, kind of like madness and stuff. So
it
I don't.
definitely makes you want to like, I don't know. You're like, really?
Yeah.
Limited.
I mean, I appreciate like the skepticism and stuff. Like I super do, but at the same time, and this is one of the things that I'll talk about again next week when we go over the scientific method, is that I feel like it's so important not to fall in love with your idea.
Mm-hmm.
And I think that flat earthers have really fallen in love with their ideas about a flat earth. So much so that even in the face of really good evidence, that they're not able to let go of their idea.
Yeah.
And it's such an important part of conducting science to be willing to, at some point, let go of a long-held standing idea. you know.
It's fun. I've been studying science for a while, and it's always funny to me how every big scientific like idea, theory, breakthrough has always been laughed out initially, like just completely laughed out of the building by every other known scientist in the room. And
absolutely,
that's just science, Someone comes up with this crazy idea that's actually pretty close to spot on, and they're just laughed out of the building. You're like, okay, cool.
Well, yeah, like even when we talked about Alfred Wegener today at the start of lecture, he was one such person where he was also like laughed out of the room, where his idea was just so radical and so like just mind-boggling, like such a big idea. The people were just like, no way. I mean, and he was also a meteorologist, someone who studied weather, and they were just like, what would you know? You studied weather.
It's sad to me too how I feel like the times have changed in such a way where, like, for instance, like Mendel and his genetics, like way ahead of his time, he was a monk with a pea garden.
Right.
Just, a garden enthusiast, just discovering the basic principles of genetics. And it's just sad to me. I feel like if someone came out of their field and they were like, hey, I'm noticing something. It's not my field. It's not my area, but I'm noticing something. People again would be like, go away. Like, you're not specialized. You don't have a PhD in that. Like, what do you know about that topic?
Exactly. And that definitely happens all the time and has happened multiple. Yeah. I'm so glad that there's someone in our class this time around who's like aware of that, because a lot of people don't know that happens and that's a really common thing.
Hallmark of science.
It is the hallmark of science.
Out of the building, like you're not a scientist, man.
Yeah, no.
You have to have a lot of naysayers.
Yeah, and part of that is healthy. Definitely, some of that is healthy and needed in when conducting science. But most of the time it goes a little bit beyond a healthy measure and it gets kind of ugly and nasty. And I can empathize and like, I can at least understand why that happens, because people are just like, that's just too crazy. I can't believe that. That's just too wild. Or sometimes if it's an idea that goes contrary to one that is already in existence, sometimes these ideas don't have one that already exists that it's combating. But if there is one that it's combating, then it can get really ugly, because I mean, you have someone who's dedicated their life sometimes to researching the previously held topic. And how is that person going to feel when you come along and are like,
life work.
just your life work, I think it's all wrong. Like,
right. Just so you know.
Yeah.
Time spent, kind of a waste.
Exactly. So, I mean, it's totally understandable that happens.
I feel like being like wanting to be a part of the science community, that you have to like walk into it knowing that like, look, I could spend my entire life trying to prove something that just isn't there, and you have to be okay with that. But in a sense, like, you're adding to the research of like, it's that like flip side theory of like Edison's light bulb. Like he found, a certain amount of ways not to make a light bulb, and you have to know the ways not to before you actually do the thing you're trying to get to. So my work could either be a bunch of ways that something isn't, or it could be a way that something is. But like more than not, you got to find the ways that something isn't before you can find the ways that something is.
Oh yeah, and that rings true not just in science. It's a lot harder because as a scientist, it's like your life's work sometimes.
Right.
But like even like with just making stuff, like making like cooking or making solutions. Like I'm pretty sure the reason why WD-40 is called WD-40 is because it was their 40th try.
I think I remember hearing something about that. Yeah, it was like they had tried 40 other products or 39 other products, and the 40th one was like, woo, finally.
Yeah, finally we got what we were trying to make, what we were trying to design. So they failed 39 times.
Significantly. It probably wasn't just like a small effort every time. It was probably like a big old effort 39 times.
Yeah. Another interesting thing too, kind of going back to like science community and that interaction when you bring up like new ideas. I actually took a class that was a bit about like the history of geology and the history of ideas and whatnot. And the instructor said, he's like, sometimes it really is about just waiting for the people who are the naysayers to honestly just like retire and get and leave the community before things can like a more radical or new idea can be accepted, because you might be a person with a new idea that is new, and you're trying to submit your research to a scientific journal, and there will just be like that one guy on the committee who's reviewing, people's work to publish or not publish, and who is just a naysayer and is going to keep being a naysayer for as long as they're on the committee until they retire. And you basically just have to wait. Wait them out. A little bit. Like that's a real thing that happens. I heard. So.
Yeah, I'm an Earth Systems Science major. Well, going to be, and it's going to be interesting. I'm definitely interested to see like what that career holds for me, but I'm hoping it has like a lot of different avenues, and that's kind of one of the reasons I wanted to get into it too. Is I didn't want to get too specialized because I don't want to feel boxed in. At the same time, like have, I don't know, just like a broad enough range, but I would like to minor in wetland ecology.
Okay. Did you say wetland ecology? Okay, that's awesome. We have so much like wetlands out here too.
Yeah, it's a perfect area for it.
Yeah, it really is. And I wish I knew more about wetlands. Like I know that they're really important, and I have some basic understanding of wetlands, especially as they pertain to geology, but not so much like the biology aspect of it.
Yeah, the biology aspect is like, from what I understand, you can think of wetlands. They are pretty fragile, especially in a world where climate change is very real. And so it's like, you have species like amphibians, which are just going extinct faster than you can count amphibians. And I think especially since they live in those type of wetlandy areas, especially up here, like there are a lot of native frogs from Oregon and Washington that are just going extinct left and right. And they're like, holy crap, how do we save these guys? They're a part of this ecosystem. And so it'll be interesting. I'll see what, that actually brings me to. But some of it, they said you can do work with like the military and help them kind of understand their own environmental impacts, which is really cool. So that could be something.
That's awesome. Yeah. So right. I have a friend who works with like the Army Corps of Engineers, right? And she does geology stuff for them. So yeah, there's definitely an avenue for like a lot of like government wanting to learn more about this kind of stuff and whatnot. So that's really cool. So I definitely need to like Earth System Sciences? Because that's like a major that I'm not really familiar with as much.
It's really new. It kind of spawned from the environmental science degree path, and I'm trying to apply and get acceptance to UW-Bothell right now, and they just this is a brand new major for them, which is kind of scary, kind of cool at the same time. But basically, they split it off from the environmental science path that they had, and they kind of dug it into two. One that was a little more fixated on the harder science with if you look at the coursework, it's going to be more chemistry, more physics, more just your harder science field, and then the other side of it is more just conservation, ecology, which I'm still interested in that side of things, but I also would like to make money for a living. So
yeah,
I wanted to do something that was still enough in the hard science field that I could have more prospective job openings, but then still have that kind of environmental science aspect to it. So
yeah, absolutely. I definitely recommend to people looking at those kinds of avenues that having the hard science type classes under your belt can really give you a leg up when you're looking at different job positions. And it just can kind of put you ahead of the game, because if you have that plus, say for in your example, plus the ecology stuff, then there are more job opportunities that are available to you where you have the prior knowledge. Not that someone who doesn't already have that knowledge can't apply for that and then learn on the job maybe.
Yeah, those things aren't as easy to learn on the job. Learning physics on the job would be rough. Or learning higher tier chem on the job would be really intense.
Yeah.
Without that prior knowledge from coursework. So I'm hoping it does those things.
Right. Absolutely. So, and it just kind of gives you, it just opens more opportunities for people when if they're going into something that's kind of sciencey and they have those harder sciences, under their belt. So for sure.
Definitely. Oh, and really quickly, sorry, I'm being distracted.
Oh yeah.
The second question I had, the lab, I feel like the rest of it is pretty okay. That was just the one question. I was okay, I feel like this is kind of ambiguous. The focus questions,
yes.
How in depth are you wanting us to go on those? Are we talking about just a pretty decent paragraph for each question, or how in depth?
Probably not even necessarily a paragraph. If you wanted to answer it in bullet points, even that would also be fine. Or they don't need to be in depth, just enough to get across the point or the answer. Nothing too crazy there.
Cool. It's when you're starting a class out, it's kind of the first couple assignments, you're getting an idea of okay, what is realistically required here. Should I just go on and on and on and find as much information as physically possible?
No. And they're definitely meant to more as a guide for people as well, to kind of as you guys wade through all this information that I want you guys to wade through all of it, draw your attention to the big concepts and you have to get this one. This one's foundational so you can understand the rest of stuff, or just kind of also sometimes they're designed more to draw your attention to some side things that people might not have focused on otherwise.
Yeah. And then I just had some questions for any upcoming quizzes or just different things of that nature. But basically, are these focus questions and other questions like them, are they going to be pretty similar to the types of information that you're wanting us to know for those quizzes or exams or any sort of tests?
They probably won't be the same questions, but the type of content that I'm drawing your guys' attention towards is definitely a good candidate for stuff that might appear on a midterm or on the final. Not all of them will, but it's definitely like in the very good candidate category for stuff that I might choose to put on an exam. But yeah, they're usually not exactly the same unless it's something that I really want to like hit home and drill.
Right.
Yeah.
I think I'm just trying to get an idea of like to set myself up and kind of start setting up my own study guide a little bit, like as we progress through each chapter, and like what are the main points that we're expected to kind of know for those exams, and then more on like a conceptual base, like okay, like this one's really important, and then because we're going over like history, kind of brushing over the history of plate tectonics right now. Like, is that also going to be a relevant topic for exams, or is it just kind of like, this is a cool thing?
I tend to just kind of brush over the history more so that people can understand the context. And also sometimes because some of the history ends up being like really cool or just, interesting. Excuse me, but I typically don't quiz people on things like names and dates and stuff like that because I hated getting those questions when I was a student.
They seem slightly useless sometimes. It's just like, I don't know. When you're thinking about like the concept of plate tectonics, I feel like it's more important to really grasp like what's physically going on rather than like, oh, this guy this one time saw something.
Yeah, I'm definitely with you there on that, where I'm more interested in having people understand the concepts of like what's happening and what's going on geologically to to cause these phenomenon that we're observing, as opposed to like names and dates.
Right.
Not that the names and the time periods in history aren't important or like, massively shape stuff. It's just that like, I think that the content that I like to focus on more is just like, do you understand what that person was understanding or what they were starting to lay the foundations for?
Definitely. Okay. I feel like I have a pretty good idea.
Yeah, and my exams tend to have like a multiple choice section. They tend to have short answers, as well as like some visual questions where you'll be asked to like look at something, because geology is a very visual subject. Right. So like, can you look at this picture and assess from the picture what's going on?
Right. Yes. Some of those, that's what I always expect mainly from classes at this point, is that there's going to be like some conceptualizing, and then there's going to be like a critical thinking element to them as well, and a devising for yourself based on the material you've already learned.
Right.
So, yeah, awesome. Yeah. I'm so sad about the whole Mount St. Helens thing. That's really
I know. Bummed. I'm so bummed.
I read that on there like one of the first, like a couple weeks ago, and I was like, oh, Mount St. Helens, and I was like, oh. Like, it's not gonna happen.
Yeah, no way. I know. I think that's definitely such a it's an unsung casualty of COVID-19.
So cool too. I love field trips. I did a geography field trip last year, and we went around and did a bunch of like ocean testing in these different sites, and like geotagged them all. And
oh, cool.
Yeah, and this class has been doing it for a couple of years now, and so you can like pull on the data from like past years and past quarters from different students and see how like the different like water salinity or temperature or different things like that, acidity has been changing in the certain like bays and ports throughout the years.
I love those kinds of classes where it feels so much more like you're actually a part of it, and right. Sometimes goals, I would love to like do some of that stuff in my classes. What class is that?
It was physical geography with Carrie Listy.
Phys with Carrie. How might her last name?
And then his last name is Lyste. He's awesome. I love Carrie. We ended up staying a couple, like it was a weekend overnight at this army barracks. And then we had like rented vans where we like just went out and like did some field work for like 3 days. It was super awesome. And then you get to geotag like a bunch of different like deadheads on the beach, and it helps them track them, and then you like tag them with these little tags. I don't know. It was just really cool for me because I'm like a physical earth science person, so I'm like, woo, it's awesome.
Right.
People have complaints, whatever. Maybe don't be in this class. I don't know.
Yeah, I mean that's kind of like the general idea, right? Let's see.
Right.
I've got someone else who's requesting if they could join us. Another student, looks like Noah is wanting to hop on too.
Mm.
Let's see, I'll send an invite there. So, because I kept the YouTube live stream up, I got an email. So, all right, maybe we will get Noah to hop on here. Message retracted. Oh, maybe he doesn't want to. Denied. Or maybe Noah just would prefer not to have the email up there. Which I can also totally understand. But yeah, I've actually think now that you described the class, I believe I have heard of this class and this instructor, and I really need to get in touch with them and find out more about like how they do stuff and their methods and whatnot.
He's really, really cool, really laid back, really chill. So he's no one scary to get a hold of. He has a dachshund named Georgia that comes and joins him on his little video messages because I'm taking a different class of his right now, actually, to fulfill my diversity requirement. It's like world geography with a diversity requirement. And he just hops on like a video thing. He's like, okay, here's today's stuff. Here's my dachshund, Georgia.
I love it.
Oh, he's super cool. But yeah, it's really cool when you feel like not only is your field trip like really just rad in general, but it's like actual data. He said, I forget who uses it, but there's like potentially a government agency or like basically the information is available to help other people who are studying similar things in the area. And it's like we've essentially kind of done their job for them a little bit, just, you know, collecting some free data.
Yeah, that's like what grad school is.
It's a lot of work for free.
Oh, I think that I accidentally may have gotten maybe, let's see if I can try Noah recent email address. There we go. Let's see if that causes anything to happen. Okay. Yeah, did you have any other questions too that I can answer for you?
I think that was mainly it for now. I think, yeah, like I said, I'm just looking through the rest of the lab just to make sure there wasn't any other questions that I had like thought of earlier and then forgot about. As soon as you said hotspots, though, I'm like, oh, let's talk about Yellowstone and how terrifying that is. Just a wonderful little ticking time bomb, just chilling, hoping it doesn't do anything eventful in our lifetime.
Right. I'm so bummed too because that was another thing I was going to do this year is in September, I was going to go to Yellowstone, but who knows if it'll be safe by then or not to go to Yellowstone, if anything will be open. And so, because Yellowstone is kind of like, it's one of the many like geologist meccas,
Right. I was going to say, if I were a geologist, I'd go to Yellowstone. Apparently Banff is really, really crazy cool.
Yes.
Because it has, from what I understand, I think it has the largest amount of fossils on record that you can just like, because I think my biology teacher last quarter was talking about this, where you can just go to different like places in Banff and like just pay your money and they'll let you go like dig for fossils. I'm like, this is crazy. It
Yeah.
just has you as like a tourist gig, like, oh yeah, just go digging, you'll find something.
Yeah, there's a place like that in Washington too. It's kind of
Oh,
far
in
away.
Curlew. I know this one.
In
Is
Curlew?
it?
That might not be the same one.
Okay, well, there was one in Curlew. It's this random, like, northeastern town that my boyfriend's family vacations in every year. And the only cool thing I thought was going on in Curlew was the fact that they have, like, fossil digs going on.
Yeah, the one that I'm familiar with is called Stone Rose Fossil. And it's also like northeastern in our state. It's in, what is the name of the city? I can't remember at the moment. Yeah, I can't recall. I think it's Republic.
Yeah, which is right next to Curlew. So yeah, it's the same.
Oh, is
the
it?
City of Republic is like really, really close to Curlew. So yeah, it's probably the same one.
Okay, yeah, I bet. It's
just like it's the lake that's kind of due north of that.
Mm-hmm.
But I think Lake Republic is the nearest bit of civilization.
Republic is so small.
It's very tiny, and to call it civilization is a little bit of a laugh in itself. But yes, in comparison to Curlew, it is civilization.
Yeah, it's definitely. I've been in a lot of small towns though, like because I've interested in doing geology, and I've done like some both for classes as well as just like side tours out of interest and whatnot. I have been in some really small towns, and so Republic is by no means like the first tiny town I've been in. I think the smallest one I was in one that was even smaller called Hanksville in Utah. There's a dinosaur dig near there that is owned by a university and stuff. And so, but literally there's just like a few homes on one side of the street. There's like a gas station and a convenience store and like a few homes on the other side. There is a cheap motel and a restaurant, and they're owned by the same person. I wonder if he owns the gas station too. Just like,
I feel like in those like old movies in the 80s when they're like visiting an old town and like the same person basically owns like 50% of the shops on like the main strip, Oh
yeah. So yeah, and when we got into town and we met the guy who owned both the restaurant and the motel, he was wearing a t-shirt that said, "Where the hell is Hanksville?"
It's accurate.
Yeah, it was hilarious. So I enjoy that self-aware,
At least they know.
Right. And I have a feeling that their motel is probably largely for like scientists and stuff, or rock hounds who are illegally rock hounding.
Those rebel rock hounders.
Right. I definitely I understand like some rebel rock hounding, particularly at places like beaches where people like tourists go and just destroy everything anyways, right, because they don't know what it is or don't care. But like there are other things where like I definitely am not a fan of people like going out and raiding places that are owned by like universities and museums and places that are trying to actually like record this data and study it. So yeah, I'm really about the preservation of knowledge. So in areas where it's not being preserved, that's a shame. And in areas where like people are stealing and causing a lack of recorded knowledge or preserved knowledge, then that's kind of like a bummer. Yeah. So, yeah. Well, I don't think Noah's. I sent an invite, but I don't know that he's gonna join or what's going on there. So I think I'm gonna end the live stream. Let's see.